In this video, we're going to be talking about the quotient of powers property, better known as dividing exponents. So the key concept, we're going to be dividing powers that have the same base but different exponents. Okay? And in order to do that, in order to divide powers with the same base, we must subtract their exponents. You can see where it says symbols that here, if you look at it algebraically, we always have a rule. And our rule here is that we have a to the m divided by a to the n equals a m minus n. You can also rewrite this, and I like to write it a little better as a fraction. So it would look like a to the m over a to the n equals a m minus n. You can see in our example, we have 2 to the 4th divided by, so we have 2 to the 4th divided by 2 to the 3rd equals 2 to the 4 minus 3, or 2 to the 1st. We can rewrite this as 2 to the 4th over 2 to the 3rd. Now, also, your 2, 4 minus 3 gives us 2 to the 1st. Let's look at a couple more examples. So in this bottom example, we can see it's our question is 2 to the 7th divided by 2 to the 3rd. Now we can show exponents through repeated multiplication, and we know if we expand this, 2 to the 7th is 2 times 2 times 2 times 2 times 2 times 2 times 2. All over 2 to the 3rd, which when expanded is 2 times 2 times 2. We know that we can cross some of these out from our previous lesson from yesterday. So 2 over 2 will cancel out. The second 2 and 2 over 2 will cancel out. And the third 2 over 2 will cancel out, leaving us with just a 1 on the bottom. And then you can see that we are left with the 4 2's up top. So we're left with just these 4 2's up top. And when I put that back into exponential form, meaning a base with an exponent, we can see we get 2 to the 4th power. Okay? Let's go ahead and look at a couple more examples. And you can see that our first example is 8 to the 5th divided by 8 to the 3rd. When I expand 8 to the 5th, I get 8 times 8 times 8 times 8. So I get that up top. And then 8 to the 3rd on the bottom is 8 times 8 times 8. We're going to go ahead and cancel out 1 8 on the top with 1 8 on the bottom. Because we know any number over itself equals 1. When I do this, I am left with 2 8's up top. I could also write that as 8 squared over 1. Or simply just 8 squared. Looking at our second example, we have c to the 7th divided by c squared. And you can see that I have expanded the top and the bottom. So we're going to cancel out a c on the top with a c on the bottom. And then another c on the top with a second c on the bottom. And now I have nothing else to cancel out. So we're going to count up our c's that we have left. And we have 5c's up top, so I can rewrite that as c to the 5th. You could also look at it if you're tired of writing them out like that. We learned yesterday you could also write it like this. C to the 7 minus 2 power equals C 7 minus 2 gives us 5. So either way, you will still end up with the same answer. Okay? Example C, we have d to the 4th divided by d to the 8th. I've expanded it already for you. I'm going to go ahead and cross out a d on the top with a d on the bottom. And keep going till at least one of them runs out. So I ran out on the top first. So that means that I'm going to have a final answer with a 1 on the top. I'm going to get a fraction. And I have 4 d's being multiplied on the bottom, so I get d to the 4th. We could have also looked at it as d 4 minus 8. And we know that 4 minus 8 gives me d to the negative 4th. And we know that we can have this negative exponent, because negative exponents give us what? Yep, they give us reciprocals. So either way, we still end up with the same answer of 1 over d to the 4th. Looking at our first example here, we have 3 to the 9th divided by 3 squared. And instead of expanding everything and then crossing out, I'm just simply going to write this as base 3 with the exponent 9 minus 2. Again, when I simplify that even more, I rewrite my base 3. 9 minus 2 is 7. So my final answer is 3 to the 7th power. We do it again. Here, I have b to the 7th divided by b to the 6th. So we know that our base is going to be b. And our exponent, 7 minus 6. So I get b to the 1st. Here we have 4 to the 5th divided by 4 to the negative 2nd. This negative doesn't belong there. When I go to divide this, you need to be super careful about this one, because I have a base of 4. And then what's going to happen is I'm going to get 5 minus a negative 2. Now, what happens when we have those two negatives together? They become positive. So my final answer is going to be 4. 5 now plus 2 is 7. So my final answer is 4 to the 7th. You need to be very careful when you are subtracting exponents and you have a negative exponent on the bottom, because you have to be super careful that you don't forget to do this positive sign, to turn those two negatives into a positive. Super important. Last example. Alright, so we have a base of s. Our exponents, we have negative 4 minus 1. Now this is a different case than the last example because our two negatives are not together. So I'm going to rewrite. My base is s. Negative 4 minus 1 Negative 4 minus 1 gives me a negative 5. We all know this is what I like to call my B answer because we know that that negative exponent creates a what? Yup, creates a reciprocal. So I'm going to have to move that. That's not what I wanted to write. So I'm going to create a reciprocal and get 1 over s to the 5th. These problems are going to be your homework for tonight, and I would prefer you to do them in either Notability or on. I will upload them to iTunes U as well. They're also on the back of your worksheet, but preferably either in a notebook or in Notability would be where I would like to see these being done. All right? Thanks very much. See you later.